Okay, so now we're going to talk about the last part of the intro. And remember, we're just laying the foundation so we can talk about cooler things in the future. This is just the groundwork. So two polygons are similar if corresponding angles are congruent and corresponding side lengths are proportional. Or you can think of similar. It's officially proportional or similar. And we're going to talk about all what that means here in the future. All right, so really, see how this says A, B, C, D, a squiggly line, E, F, G, H? This is the notation for similar. And this is a similarity statement. So just how we had a congruency statement where you stated things were congruent, this is a similarity statement where you're stating things are similar. Okay? So the corresponding angles are congruent. So how A and E are both the same, that means that's going to be congruent to that, and so on and so forth. B and F, C and G, and then D and H. All right. So I'm actually going to write all that out as well. Just be a little bit tedious right now. Again, we want to master these basics first so we can be good at the hard stuff later. So angle C is congruent to angle G, angle D is congruent to angle H. And this part right here is going to seem a little bizarre, maybe a little extreme, tedious, whatever, but it's really going to help us in the future. All right, so corresponding side lengths are proportional. So A, B, and E, F, we can write that as some fraction. A, B is corresponding to E, F. When we plug in those numbers, that's going to be the same fraction as B, C, and F, G. Because notice that those sides are also corresponding. So if you take corresponding sides and write it as a fraction, those fractions are all going to equal each other. And we're actually going to do a problem like that down here below. All right, so I'll pause a second, make sure you have that written down. But that's the corresponding fractions. They all equal each other. I should have said corresponding ratios, maybe. They all equal each other, so on and so forth. All right, so right here, let's actually do part B first, because that's what we were talking about right here. Make that a little bit more concrete. All right, so I'm just going to pick TR first. Well, that corresponds to ZX. So I'm with TR over ZX. Well, that's going to be 25 over 15. Well, what about TS and ZY? TS and ZY is going to be 30 over 18. And then the last one is RS and XZ. Or excuse me, XY. That's going to be 20 over 12. Now, little spoiler alert, these all equal each other. All right, they all equal 5/3. So when it says check that corresponding side lengths are all proportional, that's what it means. If you take the big triangle, put it over the small triangle, any of the corresponding sides, you get the fraction 5 over 3. So that's what that means. Now let's do part A where it says list all pairs of congruent angles. Well, remember, these similarity statements are powerful in themselves. We don't even have to look at it, at the picture. I can just look at the similarity statement and know that angle R is congruent to angle X. Similarly, I know S is congruent to Y. I don't even have to look at the picture. I can just analyze the similarity statement. All right? So that's what that means. We'll be doing a lot of this in the future. Again, we're just laying the groundwork today and right now. All right? And then here is the last problem of the day. All right? One way you can determine if two figures are similar is to verify that all corresponding pairs of angles are congruent and all corresponding pairs of sides are proportional. Key concepts: corresponding side lengths and similar polygons. If two polygons are similar, then the ratio of the two corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So basically, what that's just saying right here is 5/3 is like the scale factor. All right, if I took this smaller triangle and multiplied everything by 5/3, I would get those side lengths right there. Or I could go the other way. If I wanted to go and reduce it, I'd be multiplying by 3/5. So it just depends on which way you're going. Am I enlarging it? Am I getting bigger? Well, I need to be bigger than 1. Am I reducing? Well, then I need to be smaller than 1. All right, so this last example right here, determine if the polygons are similar. Well, first we need to check angles. Angles, we're just gonna write all angles congruent. All right, we're gonna be a little lazy, we're not gonna write it out, but we can clearly see all the markings match up, arc marks and right angles and all that fun stuff. So all angles are congruent, check. Now we need to do corresponding side lengths are proportional. All right. So this first one I'm going to look at is FG corresponding to ZY. So I get 20 over 25, which reduces to 4/5. I get FJ over ZW, 16 over 20, which reduces to 4/5. Then I got JH and WX, 12 over 15 equals 4/5. And then last, I got GH, which is 24, YX is 30, so 4/5. All right, so all are proportional, so they are similar. So we'll put a smiley face. Hooray. All right, and that's that for these notes.